Hey, welcome everybody. Thanks for everybody for joining this Learn Live series on building intelligent apps with Azure Kubernetes Service. We have a great lineup of content that'll get you ready to deploy and run your AI workloads on AKS like a boss. This is the first of a 4-part series, and in this one, we'll just be getting started and getting to know what intelligent apps are and deploying them and running them on AKS. For those of you that don't know me, my name is Paul Yu. I am a cloud native developer advocate here at Microsoft, and I have a special guest with me here today, Brian Redmond. Yay!
Hey, you can see me waving.
Yeah, Brian, do you want to go ahead and introduce yourself and tell us what you do here at Microsoft?
Yeah, absolutely. Happy to be here. Happy to be talking about intelligent apps.
Yeah.
My name's Brian Redmond. I'm a product manager on our AKS and Cloud Native Platforms team. Basically, I'm on the product team. My focus is working with our customer and community efforts and directly connecting with our AKS customers. I've been working with AKS since the days before it was called AKS. So I love it, and it's my life now. So happy to be here.
Trivia question: what was it called before AKS?
Yeah, many might not know that it was called Azure Container Service, and it was
Ah,
a choice of Docker Swarm and Mesos, DCOS. If you really want to be in some serious pain, go look at Mesosphere and try to get it to do anything. So, yeah.
oh man, that's hilarious. And you've also recently launched the AKS community channel on YouTube, right? Which we are streaming to, by the way.
Yeah,
So
yeah, it's super cool that we're streaming there and everyone can see our goofy wave on our
yeah,
video permanently.
yeah. So that would make me a guest on your show then.
Great. Yeah, yeah, exactly. Yeah,
Oh man, that's
yeah, awesome.
awesome. Yeah, thanks for being here with us. Um, we also have my teammate, Steven Morawski, who's also on the Cloud Native Advocacy team. He's kind of behind the scenes moderating the chat. So be sure to drop a message and say, hi, Steve. If you have any questions or comments along the way, if you want us to stop and answer something, just drop a note in the chat. We'll be more than happy to do that. So thanks for taking care of that for us, Steve. Um, this session is intended to be a live hands-on workshop. So if you haven't already done so, go ahead and navigate to that URL. Hopefully it's easy to make out, or take out your phone, snap that QR code. It'll take you straight into the hands-on learning content. So we'll be working through that. But I would say that this session is being recorded. So you don't really have to follow along if you don't want to. You can just sit back and just kind of watch it as I go through it. I'll be going through it. I'll be going through it live. So if you want at your own leisure, you can always head back to the recording and work through the content that way. So
It's pretty reasonable to do this alongside. It's not super complicated. So I would encourage people to try it out. You really can probably keep up, and Paul's such a phenomenal instructor in this kind of world. So yeah, I hope people can try it out with us.
yeah, yeah. So if you've joined any of our intelligent apps on AKS Learn Live sessions in the past, like I think we did one back in the fall, it's going to be similar but different. Um, and both AI and AKS moves at an incredibly fast pace. So we want to show you some of the cool enhancements. I know we're fresh off the heels of KubeCon and Microsoft Ignite, and we're actually heading into another KubeCon really soon. So there's a lot of cool updates that Brian will be able to share with us today. But first, let's talk about what we mean by what are intelligent apps. So what does that mean to you, Brian?
Well, it's funny. Intelligent apps, I don't know if it's like a term we invented, but I think really to me it means incorporating things like AI into maybe a cloud native application. It's not really new. I think there's certainly a lot of hype going on right now around AI and AI applications. It's not new, but I think it's been made much more accessible with some of the innovation that came out of OpenAI. It's much more possible for companies who haven't done this kind of thing before, that don't want to necessarily figure out how to pull down existing models and retrain them on their data and build their own, say, generative AI solution. They're now able to just take advantage of hosted models, perhaps give them additional hints about business specific things and actually get started. And so we're really here to help customers understand how to do this. And companies come to us and say, hey, we're already doing this and look at the cool thing that we've made. And so we're seeing very quick, rapid adoption of this technology. McKinsey tells us that there's anywhere from 2.6 to 4.4 trillion dollars of value added with this kind of technology. Let's say they're off by 10%. We're still talking about trillions of dollars, and certainly we're seeing companies really change dramatically what they're doing. And again, it's not really new. Like you think about companies like Uber, Amazon, using AI to run their business. They just really relied on that. Their whole business was built on AI. And we're starting to see more traditional companies realizing that they can actually provide a completely different experience for their customers by bringing this technology into their environment. And it's changing really fast. These are still shots from videos created by a new OpenAI model called Sora that was announced over the weekend. And it's
And
mind-blowing.
when you say new, yeah, they're super new.
Yeah, yeah. When I saw it, I was like, no, these cannot be computer generated videos. Like up in the top right of this screen, you see that Will Smith video where he was eating. It was generated in 2023. It was terrible. It didn't look like a person. He actually put out a parody video over the weekend of him actually eating something. But regardless, you can see the power of it. In fact, I remember someone explaining that like the models can't create human hands. It had a lot of trouble with hands and fingers.
Mhm.
But you see some of these new videos that came out of the weekend, and they're not struggling with that at all. And it really changes things. I mean, imagine if you want to be an influencer with your little corgi, you have to get a corgi, train him to do things, and all of this kind of thing. And someone can create an influencer without ever leaving their room. So frightening what it can do, but also amazing what it can do for us. So
Yeah, yeah. I think one of my favorites is the pirate ships battling in the mug of coffee there.
yeah, yeah, it's certainly not something that that is a pre-existing video. I think the examples they chose were trying to think up something where this doesn't really make sense. So it's
Yeah,
amazing the model can still do it. Yeah, absolutely. So it's definitely a shift over to what we really use the term generative AI, and I think that's the big probably shift from again the machine learning and AI that companies have been doing for quite some time. Obviously, it can mean smarter chatbots. There's nothing more frustrating to me than deciding to use that stupid chat box with a company I'm working with and having it just completely not understand my situation. Generative AI actually allows these applications to actually be a bit more intelligent about it. Say, oh, I recognize you're my customer. Here's your loyalty data. How can I actually help you? And companies are changing things. And it's not just chatbots streamlining business operations. Requests are coming in. They can actually do a bit of processing and start portions of the business process that are typically repeatable and identical every time. And so companies, again, are coming to us and saying, look at this we made across all kinds of industries. And it's pretty amazing the shift that this technology is bringing. Where does it fit into Kubernetes? As I said, I'm a AKS person. I care mostly about Kubernetes. I think we need Kubernetes and cloud native technology to do this. We some of the sort of high level benefits about being able to innovate faster and achieve better levels of scale and reliability. Those things are certainly there. But if you think about machine learning and AI in general, it's a phenomenal fit for Kubernetes. Kubernetes is great at elastic scale and spinning up compute as needed. And if I'm, say, training a model that I'm building, I need something that can spin up a large amount of compute, perhaps with the very expensive GPUs, and only use them while I need them, and actually spin all of that down and not pay for it. Perhaps I'm only training my model certain times a day or certain times a week. It also helps me serve up those models in a complete network architecture that takes care of a lot of the implementation for me. And so we'll talk a little bit more about how Kubernetes and AKS fit in to these intelligent apps, but I think cloud native technology is quite critical to it. I'm also certainly biased. I believe AKS is the right platform for these kind of applications. And these are
So do
some great
I.
examples. What's that?
I was gonna say, so do I.
Right, right. I'm certainly biased, but I also think these examples are pretty powerful. I mean, think about like Teams calls, entire large meetings, and generating AI-powered recaps and so forth. All of that running on AKS. Massive gaming platforms in Xbox running on AKS. Certainly can reach scale that is massive compared to often what most companies wouldn't even need. And so again, we have this battle-tested platform that can handle these types of experiences, along with some pretty amazing customer stories of customers of ours that are using it for their business. And certainly a great example, we're talking about AI and things like ChatGPT. These things were built on AKS. So the models that we're using for OpenAI were trained on AKS using things like Cosmos DB and GitHub. We believe this is a powerful message. If you're building AI-based intelligent apps, you may want to use a similar platform that can certainly handle this type of scale that's out there. Now, when I talk about AKS, what we do in AKS is we try to layer on top of typical Kubernetes some functionality that makes it much easier to use. And so AKS is a lot more than just managed Kubernetes. It's layering on top of it the things that you typically need to build these kind of applications. Particularly if I'm an AI developer, I don't necessarily want to learn Kubernetes. I may want to do things like CI/CD, blue green deploy, and so forth, and not necessarily have to figure all that out. And so we layer in technology. There's a feature called AKS automated deployments that allows me to just point to my code repo, and it'll actually generate the Docker file, the Kubernetes manifests, a full CI/CD pipeline, and actually allow you to put that right into production very easily on top of Kubernetes. And that's the kind of thing we do around either application developers or even for the infrastructure folks that need to keep the platform up to date. We can take care of things like upgrades for you. So it's essentially like my iPhone. I'm just clicking that button and saying, auto upgrade my phone, but maybe don't do it during the day because I use my phone for things that are important. And so we can do the same kind of thing with AKS. You can say, hey, my business is 24/7, but I really only want upgrades to occur in these windows, and I want to ensure that you maybe wait before you upgrade the next node in the cluster so that we can ensure that it's actually healthy. So we're doing a lot to make those things really be abstracted away so that people can really focus on these kind of intelligent apps. And when we think about learning Kubernetes or even AKS, it sure would be great to take advantage of AI technology there. And so there was a stretch there over the last year where it seemed like we released a new Copilot every day. I don't know, Paul, did we release a Copilot today? I mean,
I wouldn't be surprised if we did not.
yeah.
Yeah.
It's I don't know if it's an odd day or an even day, but regardless, the Copilot for Azure is actually quite powerful. If you think about just again an AI developer having to learn Kubernetes, maybe they're just a user of Kubernetes and they need to do a few simple tasks. They don't want to become a Kubernetes expert or even an Azure expert, and so we can turn to Copilot and ask it pretty interesting, pertinent questions to running the environment. It comes back with all the commands that you need. So we'll be doing this later today in the lab, right, Paul?
Yeah, we'll be testing it out. It's in preview, but we'll see what it can do. What kind of magic it can do.
Yeah, awesome. That'll be fun. I've got some questions lined up, some tough ones. So,
Sure.
so what else do we do? I mean, the observability is really key. You're running an environment like this; it's fairly complex. You're building really meaningful business applications on top of AKS. We provide platforms for monitoring on top of it that are fully managed services. Prometheus and Grafana are probably the most common tools, especially customers that are working with kind of CNCF based open source solutions. Typically, we'll use these technologies for monitoring. And so instead of asking customers to spin up infrastructure to run these things, we actually will run them for you. And so you can say, I just want to manage service of Prometheus, and I just want to wire it up to my cluster. And it's a single line in your infrastructure as code deployment to say, okay, this cluster is going to use this Prometheus. And then it just appears in your Grafana dashboard, which you also don't need to manage and run, taken care of for you. And then you can pull in the sort of community of dashboards and things that are out there and customize this for whatever you need.
Yeah, and I think we have a whole episode dedicated to this. So I think episode 3, this is just a teaser. We'll be covering some of this stuff. So
Yeah, it would be good for people to see some of the detail of how this kind of works under the covers. As certainly the managed Grafana, it's not that hard to run a Grafana infrastructure, but I don't necessarily want to go through that and have that responsibility on my infra team. I don't want to have to think about identity management and giving people access. All of that stuff's taken care of for me with the manager.
Or even like running it in cluster and taking up cluster resources and things like that. This is totally like managed and handled by Azure, which is super cool.
Exactly. Some other innovation that we've done in the platform, I wish I had hours to talk about all the cool stuff we've done recently. As Paul mentioned, we make announcements around these events. One of the things that we had a public preview around that's currently in preview is called Node Auto Provision. And basically the idea behind this is that the cluster autoscaler that's built into Kubernetes is somewhat dumb. I'm not being mean, but it's going to scale out particular node pools or parts of the cluster just based on, hey, I'm out of room. It's not necessarily scaling the right VM at that moment. And so if we have a node pool with these 8 core or even more and large amounts of RAM, and we have this tiny little application, and it just so happens that there's no node available for my tiny little fractional CPU application. I'd hate to spin up a 32 core multi-gigabyte VM for this tiny little application. And so that's really what Node Auto Provision does essentially, is it takes this Carpenter open source project and builds into it the ability to take a look at an application's resource requests and limits and actually provision the right VM at that moment for that application. And it can take advantage of the existing VMs that are in it. It's very intelligent about it. It does the bin packing of deployments at a much more intelligent level to take advantage of cost information and VM type availability and so forth in the region that you're in. And so you can also give it hints and so forth. It's not completely making decisions on its own. So I can say, I want these VM classes and so forth. It's a great fit for AI-based applications where each individual sort of deployment might have special kind of workload requirements, and it will take care of all that intelligence for us. But again, using an open source tool that companies can use in other clouds and so forth, which again is one of our key tenets on the AKS team. The other thing I'd like to mention again is tied to these kind of intelligent apps is if I'm building a model or an application of some kind to expose an endpoint, I need to start using things like Ingress within Kubernetes. And as much as it should be fairly simple to build an in-cluster Ingress controller, that's often not the simplest thing for an AI developer to do. I need to wire up DNS names for it. I need to build certificates and put them in Key Vault and so forth. And that's essentially what app routing does for me. I say, look, I got this application. I want to set it up with an Ingress. Here's the details to it. And it'll do all of that work for me. Still could be sitting behind app gateways and firewalls and so forth, but it's spun up the application for me and done all that hard part and that work that could be challenging. Currently, it's based on Nginx. We'll actually be making that a choice in the future where you can pick from different Ingress solutions that we offer as managed, whether it's App Gateway for containers, Istio-based Ingress, and so forth.
That's so cool to hear, because I mean, not only is it just tedious just setting this stuff up with like Ingress controllers, but there's also like a wide variety of like, what do I choose? Like I know Istio can do it, give you an Ingress endpoint, and then there's Ingress controller. But yeah, that's pretty cool to hear that it can, that this add-on basically you can have that option and say, hey, I want Istio, or hey, I want Nginx. So that's pretty cool.
Yeah, and it's funny too, because over the years, all the years working with Kubernetes, we'd ask a customer, they'd say, we're using Ingress. Oh, what Ingress controller are you using? They'd say Nginx. I'd say, why'd you pick Nginx? And it's funny, often they don't have an answer for that question. And it's interesting. It just sort of became the predominant choice. And I think it's a good choice. And that's why we based the solution on it. But there's different choices out there. And so not only will we provide choice within app routing, but we're still trying to really abstract it away so that you don't even need to deploy the Ingress infrastructure. It'll actually do that for you, which is what this will do, but then take care of your particular application and Ingress configuration and so forth. So super excited. And again, I think it's very helpful to people that are new to these kind of environments. So enough of me talking about AKS. I could really, like I said, I talk about it all day. AKS is certainly a core part of the Azure platform for these intelligent apps. There's a lot more to it. We'll use some of these other solutions in the labs today, things like maybe Cosmos DB and so forth. We talked about Azure Managed Prometheus and Grafana. We do expect that customers are going to adopt much more Azure components to build these kind of solutions. And this is frankly a smaller version of this chart. If you really pulled up kind of everything that was in Azure that could help you build these apps, the chart gets to be an eye chart and it becomes way too big. But this is at least probably the right subset for this discussion. So.
Is it as big as the CNCF landscape chart? Because that is.
Well, that's a goal we're trying to reach. I mean, it's going to be hard, but I think if we put our minds to it.
Yeah, because that's
Exactly.
a sight to see. So cool. I think that's a great segue to now talk about how we can start putting some of these things together, like in a demo, but kind of like almost in a real life scenario. And so what I'd like to do from here is just quickly talk about what we're going to be putting together in this hands-on workshop. You may or you may have not have seen this demo app before, but it's a sample application that we've built and put together that's basically microservices architecture, different components written in different languages, because that's just the way teams or dev teams, might roll these days. You might have a team that focuses on one particular area, and then you kind of like stitch the entire solution together to make your website. And in this particular scenario here, what we have is we're trying to, I guess, mimic a e-commerce scenario, right? So it's just a fictitious pet supply store. And we have two components to it. There's a front end where customers can browse the catalog, add things to their cart, check out. But there's also a back end where employees of the company would want to manage their products. And this is where we want to add that intelligent capability to the application. What we want to kind of reduce the cognitive load on the employees. So as they're adding new products to the catalog, a lot of times the descriptions could be hard to come up with, right? This is a perfect opportunity to leverage the generative AI models from OpenAI to help us with that. And so what we will be doing is basically we will ask OpenAI for a description. And that description will be based on the name and the product keywords. And so you just fill in those two text boxes and you hit the Ask OpenAI button, and it'll generate that product description for us. And then we can add that product to the catalog and make it available to our customers.
I would say too, I mean, like this is a simplistic example and we're just passing it some very simple data. The descriptions are kind of amazing because we've obviously been building this app for a while, tested it, and it's actually amazing how good they are. But it's also a realistic scenario. We have a public case study from one of our customers around a car company, and they sell used cars at a large scale in the United States. And building the descriptions aren't always just it's not like they're pulling it out of a canned database. Used cars are different over time. They pull from 8 different sources to create a description for the car. And so they used OpenAI and generative AI technology to replace the description building of the app. Super powerful and really shaved off a sort of wasteful administrative task for their team. So super powerful and very realistic scenario here. So.
Yeah. And like you said, this is just the tip of the iceberg, right? Like we could probably use further enhance this app and use like Dolly for image generation, or now Sora to generate the product videos, which is wild.
Yeah, our new corgi influencer for our pet store. I mean, yeah.
That's a good one. we should put that on the homepage. Cool. Well, I mean, this is the business scenario here. Let's talk a little bit about what that application architecture looks like. So I did say that we're serving two different audiences here. The first one's, it's the customer, and they land into our what we call the storefront. This is the place where they can look at the products in the catalog, add it to their shopping cart, submit the order. And so it goes through these various microservices. So we have a product service that delivers our product catalog to the front end application. And then when they're ready to check out, that order gets sent through a Node.js application out to a RabbitMQ order queue. Employees would then log into the backend or the administrative site, which we call store admin. Very descriptive names, right? We could have came up with some cooler names, but these are pretty boring and descriptive. What this store admin site does is it also pulls from the product catalog, because we need to add products, update, delete, right? When we are processing orders, what we'll do is we'll call this other microservice that we call the make line service. This will actually retrieve orders off of the RabbitMQ and push that order into a persistent data store, MongoDB in this case. Now, this is the solution to start. And we are going like pure container route here. We do have MongoDB and RabbitMQ, but those can easily be swapped out for Azure PaaS services like Azure Service Bus or Azure Cosmos DB using Mongo API. Okay. So what we're going to do is we're just going to get this up and running, and you can see there's no intelligent capabilities here. Now, what makes cloud native architectures very, I guess, very well suited for AI workloads is that typically an AI workload, as a developer, most often you're not training the model, you're not building fine tuning or any of that. Most of the times developers are just using the inferencing endpoints. And that's exactly what we'll be doing here. We will be deploying an AI service, which is written in Python, and it uses the semantic kernel SDK, the Python flavor. If you haven't seen that open source project yet, I would say take a look at that. It's basically like your AI orchestrator, which enables you to talk to various large language models, including OpenAI, of course. And so that's what we'll do. We will deploy OpenAI model on Azure. Now, this application can talk to either OpenAI directly if you have your own subscription with OpenAI and API keys, but we're in Azure, and so we'll deploy it onto Azure OpenAI. And so,
real quick, it looks like you've used like at least 4 different programming languages. There's one really particular popular technology made by Microsoft that is not on the list. Any reason why you didn't choose .NET?
I used to be a .NET programmer in my former life. But lately, within the cloud native space, I've really just explored other different programming languages. And so that's just been my preference, to be honest. Maybe we will have a .NET sample in here. Who knows? Yeah, but semantic kernel SDK, they do support many different languages, not just Python. And I think obviously it's open source product built by Microsoft, and so it has great support for .NET. So I would highly encourage you to look at that if you are a .NET developer. Yeah, so this is basically it. This is what we're going to deploy into Azure. We're going to see how to put it all together. So what we will be doing is the following. If you scan that QR code or headed over to the URL that was listed on the title page of the PowerPoint slides, you will be presented with the workshop content. And just at a really high level, what we will be doing is we will be provisioning a AKS cluster. We're going to deploy the AKS store demo application onto it without AI. And then we're going to easily provision an Azure OpenAI account with the GPT-3.5 Turbo model. Now, what I didn't include here, but I included in the other PowerPoint slide, is that we are going to be using the Azure Developer CLI to deploy all this. And I'll show you why it's pretty cool. From there, we will add or bolt on AI capabilities to the app, and then we will expose the app using the AKS application routing add-on, which Brian just talked about. And then after that, we'll have some fun. We'll talk to Microsoft Copilot for Azure, and we'll see. We'll give it some questions, some hard questions, and see how it comes back. Maybe it might do very well. All right. So let's flip over to the workshop material. And you might see scrolling by on the ticker below the URL to get to the content. If you head over to that URL, you will be presented with this page here. Now, let's see. I did go over the objectives, and there are prerequisites. So number one prerequisite, which I didn't include here, but you do need an Azure subscription. And with that, within that Azure subscription, you do need to request Azure OpenAI. What I would do is, I think you could, if you don't have an Azure subscription, you might be able to head over to aka.ms/ is it free Azure or Azure free? I'm going to try free Azure. Free Azure. Hey, look at that. I was right. You can start for free. You can try it out. You can most certainly deploy an AKS cluster, a small AKS cluster, using these free Azure credits. I'm not 100% sure about OpenAI, but it's worth a shot. Once you do have access to Azure, or if you do have access to Azure but never deployed Azure OpenAI into your subscription before, what you should do is, in your favorite search engine, just Bing search or Google search AKS and OpenAI, and that will take you over to this doc here. Deploy an application that uses OpenAI onto AKS. Down here, there is a form, right? Request access to Azure, right? So just click that, and it will take you to the form where you can actually request access to it. Okay. So this is just basically like a responsible AI checker, just to make sure that your intentions are good in using the technology. So go ahead and do that. And I would say all of the things that we're doing in this workshop, it can totally be done by following this tutorial here. The issue that you may have with this tutorial is that it could be tedious. There's a lot of like Azure CLI commands that you're going to have to run through. And I'll show you why Azure Developer CLI is a pretty cool alternative to that. Okay.
And you can also run almost all of this on a local machine. So you can spin up a local cluster, whatever type of Kubernetes cluster, and you can really run everything except the actual Azure OpenAI service. But in theory, I can run the entire thing locally. You might have to hack your way through the instructions a little bit, but actually on the repo, the code and everything is there to do it.
So. Yeah, no, I'll show you how to do it. You can totally do everything. I would say without Azure, if you have OpenAI like direct, right? If you have an API key for OpenAI directly, yeah, you can totally run everything inside of a local cluster. What I like to use is Kind, Kubernetes and Docker. So I'll show you how you can potentially do that. All right. So Azure subscription, OpenAI access is two of the major prerequisites here. And then there's like a ton of tools. Sorry for the long list here, but these are all the tools that we use to kind of get this all put together. So Azure CLI, definitely you're going to need. Azure Developer CLI, and then VS Code. And of course, Docker Desktop. That's critical, especially if you want to run everything locally. just to kind of get your feet wet and test it out. Docker Desktop, highly recommend that. And then, of course, tools to interact with the Kubernetes cluster and deployment. So kubectl, Helm, Git, obviously, because this is all stored in an open source GitHub repo. And then Terraform. You might be wondering why the Terraform's in there. So you can deploy resources using Azure CLI. You can deploy resources using Azure Portal. You can deploy resources using infrastructure as code. I am more of a Terraform person, so I put a lot of these deployment scripts together using Terraform, and then essentially, well, we'll see it in a second. Essentially, we'll use Azure Developer CLI to do that. So first thing you should do is click this link here and head over to the AKS store demo repo. Okay, so I'll click that link. And what you want to do is click this code button to open this little dropdown, and then make sure that you click the code spaces tab here. It'll default to local, but you just want to make sure that you are in code spaces. And then from there, you can either hit the plus box, or if you want to open a new code space with additional options, you can do that. But just hitting the plus box is fine. Once you open this into a code space, what you're going to be brought into is a remote, what we call remote dev container. And why do I recommend that? Well, it's because you saw the long laundry list of tools, right? You can install that all on your own local machine, or you can just use this code space, and it has all the tools that you need to get going. Okay. Now, I already have a code space spun up. So let me go ahead and flip over to it. Now, what I'm going to do here is I'm going to put the instructions and the code space side by side here. So let's see. Okay, so let me just restart my code space. So what I will do is I'll kind of put my instructions off to the side right over here. Okay. And if at any point this is hard to see, just let me know. Feel free to interrupt me. All right, so my code space is starting up, and once I get my terminal down here, I'll know I'm ready to go. Okay. So first thing we want to do is we want to get this thing up and running locally, right? Because this is a sample repo. You can see the way it's organized is it's a mono repo. Maybe some of you are working out of mono repos. Maybe some of you have different projects in different repos. In this case, it just made sense for us as a sample application, just to kind of put it all into a single mono repo. And so all of the source code for each of those services that I talked through, they're all listed here. And so this is your opportunity. I encourage you to fork the repo, clone it down, make changes, experiment with it. But as you're experimenting with it, you would want to maybe test it out locally. And so I can show you that. We can actually bring up this entire solution using Docker Compose up command. And what that will do is, if you haven't used Docker Compose before, it's basically a way for you to spin up a multi-container solution, all using a single YAML manifest file. So not Kubernetes, but I would say an easy way for you to get this multi-container thing up and running locally. So what I'll do is quickly show you what that command would look like. So Docker Compose up. What this will do is it'll actually build all the containers for you. And I'm going to warn you, it's going to take a few minutes because there's a lot of containers in there. And so once all the containers are all built up, what you're going to see is you're going to see a bunch of logs flying by. One thing that I didn't mention that's in the application, but that's not in the architecture diagram that I was showing you, is that we have virtual worker and virtual customer processes that's running as containers as well. So this is meant to kind of like simulate load on your application. And so you'll see a lot of that stuff kind of flying by. Once you have your application kind of up and running, what you can do is in your VS Code, you can hit this ports tab here, right? So there's ports, and then we do have 2 ports that we want you to access initially. Port 8080, that's the storefront. Port 8081, that's going to be our backend application. So if you hover your mouse over 8080, you can see a little globe icon. Click that globe icon. It'll take you straight over into the application. And so this is kind of what it would look like. So you can, let's say, add item to the cart, and then you can check out, and then boom, an order goes through the order service and into the RabbitMQ. Now, this order process is super simple. We don't collect any information, but it's here to kind of demonstrate how microservices communicate with each other within a multi-container scenario, and then of course in Kubernetes. So now let's take a look at what the backend looks like. So if I go back to my VS Code, I hit the globe icon for port 8081, and there we go. This page looks a little bit different, and then you can see I have a ton of orders in here. This is that virtual worker kind of like doing its thing, and then, excuse me, virtual customer doing its thing, and then the virtual worker will process these off the queue and then put those orders into the MongoDB. Now, what we want to do here is we want to click this little products arrow or link over here, and then we want to click the add product button. Now, you can see here, we don't have that button that we talked about, right? Because AI is not enabled. So let's go ahead and deploy this to Azure. Okay. So if I,
by the way, we're killing it in our store, our pet store. I mean, the amount of orders at the brand new business.
right? Yeah. Hopefully I make commission off of all these orders. So what we'll do is we'll actually deploy this into Azure so we can further scale, right? Because we're killing it locally. Maybe if we deploy this out onto the cloud and expose it to the world, we might do even better. So what we're going to do is we're going to actually use the Azure Developer CLI to deploy this into Azure. Now, Azure CLI is basically another command line tool that will enable you as a developer to do 2 things, actually 3 things, but it will enable you to provision your infrastructure on Azure and deploy your application into Azure, right? So it does require some infrastructure as code scripts, and it does support both Azure Bicep and Terraform. So it can use either or. Again, me personally, I'm a Terraform person. Steve, I would say Steve is a Bicep person. And so we have both in our sample repo, and I'll show you what that looks like. Now, there are a couple of commands here that you need to be aware of. Once you install the Azure or the AZD, is what we call it, AZD, right? There are 2 things there. AZD provision does what you think it does. It provisions infrastructure. AZD deploy deploys the application. Well, you could combine those 2 things so you're not running multiple commands. You can combine all that into an AZD up, and the AZD up will do both, okay? So what we will do here is let's go back to the terminal, and let's stop all of our containers. So these orders aren't being processed, so Brian, you won't be able to make your commission off of that. They'll just be sitting in the queue. So let's wait for this to stop. And what you need to do is 2 things. When you have both the tools, and I'll show you really quick. So inside the dev container, if you're wondering like how these dev containers are put together, just take a look at the sample repo. Just scroll all the way up to the top. There's a .dev container directory, and then there's a dev container JSON file here. This basically outlines all the tools that are installed, and you can see there's a ton of it. So hence the reason why it takes a few minutes for these containers to spin up. So so it's all in here, and we do have Azure CLI and AZD in here. Okay. The way AZD works is you drop in an Azure YAML file into the root of your repo, and you can basically have a line of code down here for infra. By default, it's pointing to our Terraform directory, and so it'll execute the Terraform. Okay. So if I go to the path here, infra, so there's infra, and then you can see here we have Bicep and Terraform. So if you want to deploy this using Bicep instead, you would just flip these Terraforms to Bicep, and it'll deploy that. Okay. And if you're curious to see how some of this stuff is put together using either of the infrastructure as code languages, these samples are here for you. And so you can see that we're deploying or it can deploy a bunch of stuff for us. So essentially, Azure Developer CLI works as a wrapper for some of these infrastructure as code tools and your deployment process, right? So it's here to make it a little easy for you. So what we're going to do is we need to log in to Azure CLI, because we're going to be doing things with Azure CLI, or actually AZD will be doing things with Azure CLI. And so it'll need our login context. And then we need to log into Azure Developer CLI as well. So 2 logins, unfortunately, for now. So let's go ahead and do that. I think I've already logged in. Let's see. But let's see. Account show. Let's pull this up. Yep, we're good. Okay, so I'm logged into both, but you would just do a AZ login and then an AZD auth login. Okay, so we'll do that. The next thing you need to do is, I did say you can deploy everything in a single command, right? So let's do that. AZD up. Okay, so it's going to ask me for a new environment name. So AZD can manage multiple environments for you. And so I will call it dev, and it's going to ask for locations. Now, you do need to make sure that you are going to deploy into a region that includes or that has all of the services available. So just to play it safe, I would say pick East US and East US 2 for now. Okay. And then you can see that it's on its way, it's doing its thing, and it's actually pre-provisioning our subscription for us. So there's a couple things that we deploy into our Azure subscription. Some of these are preview features, and so you do need to register some of those features. So the AZD will actually register those features for you. Okay, and then what it does is it'll actually go through and deploy the Terraform templates. Now, this is going to take roughly around 5 minutes to deploy, but we'll wait on that. Okay. Peeking ahead or scrolling down here. Okay, so what we're going to do is let me just walk you through how some of this stuff will be deployed as well. So as the Kubernetes cluster is deployed, let me show you what we're doing here. So in the Azure YAML, and I'm gonna call this out right now because we're going to change this. After our resources are all provisioned in Azure, what we're going to do is we're going to use what's called an AZD hook. Okay, AZD hooks allow you to do just that, hook into the deployment process and add your own customizations as needed. And so when we put this together, Helm wasn't really supported yet. I think we were developing this using AZD version 1.5, but literally like a week ago or within the week, AZD 1.6 just came out, which does have support for Helm. So we will be migrating this particular pre-deployment AZD hook into using more of the standard supported Helm deployments. Okay. And so we'll take a look at this. So what we're saying is basically before we deploy, we're going to go run a Helm installation. So if I go up to the AZD hook and if I go to pre-deploy, you can see that we're going to use a Helm chart to deploy everything. And so if you are new to Kubernetes and you just want to just deploy this thing in a pretty, I guess, a easy manner, what you can do is you can actually go to the charts directory, and then you can see in the templates. So we have all of our Kubernetes YAML manifests listed here, and they're kind of broken out service by service. And it just makes for an easy way to package your deployment for Kubernetes into any Kubernetes, really, not just Azure. It just makes it an easier process, right? A lot of our quick starts, they actually use the all-in-one, right? So here, man, how long is this YAML manifest? Scroll all the way to the bottom. 540 lines of YAML, which is...
It's a best practice, I think.
It's a little daunting, but you know why we have it is because so that we can just deploy everything in a single kubectl apply command, right? So this is here as a quick and dirty way to get it up and running. I would say breaking out your manifests by service, or maybe even packaging them into a Helm chart, or even using customize, which I particularly like. Those are best practices when it comes to Kubernetes.
I would add too, we obviously have everything in a single repo, and I think there's a lot of opinions on how you do this. Again, this is built for a demo, but a lot of companies would actually maybe break this out into multiple repos, for one for each service, so that I can do a lot of interesting things around separating them. But again, that's a architecture decision. We're not making an opinion about it. We're just kind of putting it all in one because it's a demo.
Yeah. And exactly that. It's a demo. It's only maintained by a few of us for now. We do appreciate any community contribution to the project, but a lot of times, like monorepo versus multi-repo, I mean, a lot of that is determined by like the way your teams are laid out, right? So if you have one person managing all the projects, then it's just more convenient just to have it all in a single repo. So, all right, let's see. How is this deployment doing? We do have a key vault creation complete, and then the Kubernetes is well on its way, 4 minutes into it. Okay, so we'll be a little patient there. Like I said, if you are interested in any of this infrastructure as code stuff, a lot of this stuff, obviously you can go to the HashiCorp, the Terraform registry, and there's a lot of good sample code out there. But this is here as well, and is very specific to our solution. So looks like as I was talking through that, we are fully deployed. So the application was provisioned and deployed all within 5 minutes. Let's go see what it looks like. So if I jump over to the Azure portal, what was my resource name? Did it say? Aha, okay. So resource group name, and I use these funny little random pet names to name some of these deployments, because some of the services they do need to be globally unique in terms of naming. So what is this? Wise Locust 45. That's my deployment name. Okay, so RG Wise Locust. I gotta remember that. Let's refresh, scroll down. Wise Locust, there you are. Okay, so I have a Kubernetes cluster and a Key Vault. Let's click onto the AKS cluster. Let's go to workloads and when it loads up. Okay, so there we go. I can filter this by namespace. So I know that it deployed into the pets namespace. And you can see I have all of these services here, right? What I can do also is hit that services and ingresses button. And if I just collapse this down, you can see store admin and storefront. I do have external IPs for them. So these are public IPs that I can access. And you can see that the type is a little bit different from the rest of the other services. These are load balancers. So anytime you deploy a service, a Kubernetes service of type load balancer, what you're going to do is you're going to get these public IP addresses. And this is a very handy way to just quickly test your application. So if I click on this, it should take me to, hey, look at that. Took me direct. Hey, we got our first order, Brian. All right, we're back in business. Okay, so there we are. We are basically in the same situation. Did you see that? You saw that there was an Ask AI Assistant button that kind of went away. So what we did in the application is we coded in some graceful degradation there. Basically, it checks to see if it can call an AI service. If it can't, that button goes away. If it can, then the button will appear. Okay, so we don't have that button. We need to go make that button happen. And so what we need to do is we need to use some logic that we actually coded into the Terraform. Basically, if I go to this next section, what we're going to do is we're going to deploy the AI service, and we're going to need to provision the Azure OpenAI model. So what I'll do is I will grab this command, basically setting environment variables, which will act as a parameter to pass into either the Bicep or the Terraform. And it's basically saying, hey, deploy Azure OpenAI. Yes. So I'll go ahead and set that. And then I will call the AZD up command again. And what it will do is it'll go through, but this time it's going to be much quicker. It'll go through and say, oh, you want a brand new OpenAI account, which isn't already there. Let me go ahead and deploy that. Oh, and on top of that, since you have OpenAI deployed, let me go ahead and invoke the Helm template again, but this time deploy the AI service. So this usually takes probably about 1 to 2 minutes. You know how the demo gods are. So we'll see. We'll see how it does. Okay. So what we expect is this. So once the AZD deployment is finished, we should be able to go back to our application, and then we'll be able to create a new product called Bear Snacks, which is shout out to Bear. Steve has a new dog named Bear, so we'll make a product in his name. Okay. Okay, so it's still creating there the Azure Cognitive Services account. And so if I go here to the OpenAI Terraform, you can see that we're deploying a Cognitive Services account, and then we are deploying a model as well. Okay. I would also note that this initial deployment is using purely OpenAI keys for access. There is a doc. Where is it? Here. So if you go to this doc, secure access to Azure OpenAI, this will actually walk you through how to configure all that access using workload identity, basically passwordless authentication from your pod in Kubernetes and Azure OpenAI. So it's a really slick authentication method. And I actually recommend using workload identity wherever you can. I think most services support it now. So, okay. So In about 2 minutes, we are done. So we should have everything in place. So if I go back to my Azure portal, and if I go back to my resource group and I hit refresh, you'll see that I have an Azure OpenAI account here. And if I go and head over to the workloads again on the AKS cluster, you can see that, oh, there we go. So the AI service is new. This wasn't here before. And it is kind of getting itself started here. So we'll give this just a few seconds. And then we should be able to browse to the store backend and then add that new product. Okay.
Maybe a good time to talk about the difference between running and ready.
Running and ready. Yes. So we actually recommend this here. So just because a pod is deployed into Kubernetes, that doesn't necessarily mean that your application is ready. Your application may have to go through some sort of startup processes, maybe pull data, maybe check connections, or do whatever it needs to do to actually be ready. And so what we recommend is that as you're building these microservices applications, you should actually code in a health check endpoint to determine whether or not your application is in fact ready. And Kubernetes has this concept of ready startup probes and readiness probes. And so Kubernetes will actually invoke those endpoints. And if it gets a successful response, it'll say, yes, my pod is actually ready to serve content, right? And so that's what it was doing there. The AI service was getting started, making its connections. It's a Python application, so it takes a little bit to start up. And so it actually waited until Kubernetes received a successful response code for both the startup and the readiness probe. So now we can see that's 1 of 1 ready. So now if I go to my store admin again, and okay, we have orders processing, cool. Now, if I go to add product, there we go. We have an Ask AI Assistant button. Now, what did I say? Bears yummy snacks. We'll make it easy on Steve and just charge him $2.99 for it. And we can say dog treat, dog named Bear. Okay. So then I'll hit this Ask AI Assistant button based on the keywords and the name. There we go. Reward your friend Bear. Yay. So I'll save that product. Okay. There we go. So now the product's available in the store. And I can confirm that. So if I go to the storefront, I should say. And if I scroll all the way down, there we go. We have Bear's Yummy Snacks there for $2.99. Okay. Let's load up on that. What is that? 10,000? Yay. There we go. Big order coming through. All right. So basically we deployed or bolted on AI capabilities into our existing application. And we saw that the service type was load balancer and we had a public IP. Great way to get started, great way to test, but not really a great way to expose your applications in production. And so what we will be doing here is we will be adding this application routing add-on for AKS to install an Nginx ingress controller. And then we will use that as our ingress point to the apps, right? So we will no longer have public IPs on the apps themselves. What we'll do is we'll have a single ingress endpoint, which will point to our services. So let me go ahead and show you how to do that. We could have added this to the cluster in our infrastructure as code templates, but I wanted to show you just how easy it is to do it in the Azure portal, because when I saw this, I thought it was pretty slick. So because we're still in the services and ingress section of the Azure portal, what you can do here is click on this create button. Oops, that is not what I wanted to do. Click on this create dropdown, and you have ingress preview here. Correct me if I'm wrong, Brian, but application routing add-on for AKS went GA at.
That is correct. Yeah, that's a bug basically in the portal. So
Okay. So
I'll work on that right away.
yeah, it says preview, but it's actually GA. So what this is going to do is it's going to enable the web app routing add-on in our cluster. Okay, so it's basically making an API call to Azure and just making that available. And we will have the Nginx ingress controller in our cluster once this is done. Okay, so I just wanted to kick that off because it could take just a few minutes to get that going. What that is going to do is it's going to provision an Nginx ingress controller for us. And we do have some things that we can take advantage of, things that Brian talked about, which is Azure Key Vault for SSL cert and Azure DNS. Okay, because Kubernetes services, they had no concept of SSL cert. So you couldn't tie the SSL cert to that. And on top of that, with the Kubernetes service, all you're getting is an IP. You're not going to be able to get a domain name or a subdomain name with that. And so this is where Azure DNS and Azure Key Vault come into play. And because the app routing add-on is fully managed by Microsoft Azure, the integration between these three services is like, it's pretty nice, and I'll show you. If you recall, if I go back, I'll just let this thing kind of do its thing there. If you recall, we do have a key vault. We'll use this key vault to store our self-signed SSL cert, but we don't have DNS. So let's go ahead and deploy that. I could add it to the Terraform template, but let's just go quick and dirty, and let's just use Azure CLI for that. So we'll create a brand new DNS zone, and we'll give it a funny name because it does need to be globally unique. So what I'll do here is, what I'm going to do is do an AZD get values call, which will retrieve all the values that Terraform output for us. And then we'll kind of use some of those output variables to deploy our DNS zone. So what was our name? It was like Wise Locust, right? So we should have a funny DNS, wiselocust45.com. Okay. So this is really quick. So we'll go ahead and let that command do its thing. There we go. So this is going to be the domain name of our website, which is wiselocust45.com. Okay. Now, the next thing that we need to do is we need to create a self-signed certificate. We could use command line to do that, but Azure Key Vault has a pretty cool way of doing that. So I'll go to the Key Vault, go to certificates, click on the generate. Now that might have been too fast. So Key Vault, certificates, and then here, generate and import. Click on the generate and import button, and then we just need to fill in just a few things here. Certificate name, I'll just call it pets. It's going to be a self-signed certificate, and I do need a subject. Okay, so subject equals, and this is where your domain name comes into play. So we'll just copy that domain name, and then we will paste it in there. So that'll be the subject of our certificate for now. And then just click create. Oh, and by the way, while I was talking to that, you can see that the web app routing has been added to the cluster. So we have DNS, we have an SSL cert, and we have the routing add-on installed. So we're good to go. So if I go back, hide my notifications. If I go back here, there we go, DNS zone. Now, what's going to happen is, actually, let me go ahead and get this started, and I'll tell you what's going to happen. So we'll go back to the AKS cluster, and we'll click on services and ingress. Okay. You can see here that this is of type load balancer. We don't want this, right? We don't want public endpoints. We don't want our services directly exposed. We want to go through the ingress. And so what we will need to do here is grab these commands, and this is like kubectl magic here. what we're going to do is we're actually going to patch this service, and we're going to change the type back to cluster IP. So we'll do that. Boom. It's patched. And then I will do the refresh here. And there we go. Cluster IP. So what we'll do here is literally right click. So we are definitely using ClickOps here, not DevOps. But, ClickOps is great to get started. What we'll do is say store admin. Okay. Ingress name store admin. It's in the pets namespace. We're going to point to store admin. We're going to select the certificate. We're going to choose our key vault. We're going to choose our self-signed certificate, and then we're going to hit select. Azure DNS, we already have that in place. So we're going to choose our funny domain name. This is the admin site, so we should be able to access it on admin.wiselocust45.com. Save, review, and create. And the portal is actually doing magic for us. It's actually updating an Azure Key Vault access policy, basically allowing the managed identity for the AKS cluster to be able to, and I see if it failed, of course, but it's basically allowing the AKS cluster to talk to Azure Key Vault and retrieve that secret. And then it makes a DNS zone contributor role assignment, because the add-on actually is able to write DNS records for us in our Azure DNS zone. Now, I can retry this because this typically doesn't fail. Updating the add-on with the selected DNS zone. There's no reason why it shouldn't go through, because this contributor role has been assigned. So, and this takes just a few minutes to finish up.
And the one thing I'd say too about the Key Vault is it's sort of interesting. Like, you did all of the steps, like you added the cert to Key Vault, but imagine like a real environment, a real company building these. Like, it sort of points to the separation of duties. There's probably a different team at a company that takes care of all of that Key Vault. I mean, why put it in the Key Vault if everyone has access to it? So that's that moment where, as a developer, I'm just like, they told me this is where the certificate is. I don't need to even understand that Key Vault is there. You mentioned workload identity earlier. That's like a whole thing that got set up. As a developer, I just want to expose my store and start making some money, So that it's one of those things that really does highlight that sort of separation and make sure it's easy to deploy something without having to do all of that.
Yeah. And in addition, the add-on is actually deploying the secret store CSI driver into the cluster, so that the cluster, I mean, you're just basically pointing it to the Key Vault. There's actually a resource in there that's now able to look at the Key Vault and just pull that secret down. So yeah, you just need to be able to say, hey, it's over here, go get it. So and it's all using workload identity and all that underneath the covers to pull all that. So we'll give this just a few minutes to complete. But at the end of it all, what you should get is something like, basically it's going to write a brand new A record into your DNS zone, which is going to point to the public IP of the ingress. So we don't have public IP on the services anymore. There's a public IP on the ingress controller. Okay. So we'll just kind of wait for that, and then we'll be able to test it. So let's just see. Okay. So it went through. Yeah. I kind of thought that error was something that we can just quickly retry. So we'll close that. We'll close this, and we see that we have no more public IP on that. But if I click on this ingress, you can see that it's now available. This site should now be available on admin.wiselocust.com at this particular public IP address. So now if I do something like, if I do a command like this, okay, it's actually a handy command that I just included in the instructions here, so that I can go ahead and make a host file configuration, because this is not a real domain. So what I can do is I can modify my host file. Okay. So let's jump to the end of this. Paste that in. So basically, my local system will be able to route to this. I quit, and if I jump back, what was it again? wiselocust.com. Now my application should be responding. Of course, it's a self-signed certificate, so it's not really secure. But you know what? For this demo, it's okay. There we go. So now we're back in business. There's a bunch of stuff that it did in underneath the covers. So you could kind of like follow some of these commands to see what it did. So we can see here that I have, as a Kubernetes secret, I now have my TLS certificate because it was able to pull it down from the key vault. If I take a look at the ingress, you can see that it's using the web app routing, and it's also pointing to the key vault certificate and pointing at my store admin. So you can literally do the same steps to expose your store front as well. And then if I look at one more thing here, if I refresh and I go down to the DNS zone, you can see down here that the add-on actually wrote this A record for me inside of Azure DNS zone. So it's like a lot of things going on, but just with a few clicks, we're able to configure, right? And I didn't have to write a brand new ingress manifest, which typically you need to do, okay? And I think that's a pretty good segue into the next portion. Just a quick time check. I think we have a few minutes left, so we can kind of cover this real quick. Microsoft Copilot. Okay. I think George Palma and I were on stage at last build, right? And there was an AKS Copilot, which was pretty exciting because it was doing a lot of cool stuff. In terms of like helping you troubleshoot or work your Azure Kubernetes cluster, that actually got rolled into a bigger product, right? It's called Microsoft Copilot for Azure, right? So it's not just AKS specific. It can actually help you with all of Azure, which is really cool. It's actually here to help you design, operate, troubleshoot, and optimize all of your Azure resources. Now, it is available under limited access preview. And I do believe you have to have a enterprise agreement to be able to qualify for this. So if you have an enterprise agreement and if you want to give it a try, I would say click this link here. And you only need to do it one time per tenant. So you can go here and you can actually request access to the preview. Okay. So yeah, just get in contact with your tenant administrator and say, hey, let's try this out. Once you do have access to it, and I'll show you all this in a second, what you can do is you can actually ask questions. No more Bing searching for things or no more Googling for things. You can just be right in the Azure portal and you can ask it things. So things like, designing your cluster, like one of the questions that I have here, one of the prompts I have here is, hey, what network plugin should I use for AKS if I want to ensure all communications to the outside world is disabled by default, right? So let's go ahead and copy that question. Let's see what it comes back with.
I mean, Paul, I seriously built a big chunk of my career answering questions such as this. I mean, it easily sounds like it's going to replace Brian Redmond. So
yeah, me too. I used to work as an architect and did a lot of consulting with folks. So yeah, as both an employee of Microsoft and as a potential customer, I think this is pretty cool. Now, I would note that you should take these answers with a fine grain of salt, and I'll show you. When this thing pops up, it normally pops up like a whole bunch of like, especially if you're getting started for the first time, it'll pop up and it'll kind of tell you what it can do, what it can't do. And I think if I ask it the question, and you can see it's pretty limited. So you can only make 15 requests during a given chat, and you only have 5 chats within a 24-hour period. So they're still ironing this thing out. And so what I will do is I have an AKS question, and let me back up. I found in testing this that if you're going to ask it a question about a specific resource, for me personally, I found it to be more, I guess, better responsive if I'm in the blade of the product that I'm working with, right? So if I was just like in the Azure homepage, it probably won't give me the best answers for Azure Kubernetes Service as opposed to me being in the Azure Kubernetes Service. I don't know if this is a feature or a design thing that's just the way it works. It's just I found that it's better that way. So I'm in my Kubernetes service blade, and I'm going to ask it this question. What network plugin should I use? So send it the question. And what it's doing is it's thinking about it. And it's using all of the Copilot design patterns and principles that we've been kind of talking about for the whole year since build. And a lot of that is like the RAG pattern, retrieval augmented generation. So it's basically taking your question, going out and searching through existing documentation, deciphering that content, and then coming up with the best solution for you, right? And so here, let's see.
And you asked it, you added, a kind of a difficult language part you put in there about no access to network communication to the outside world. Like, that's not, that's pretty cool. Like, that isn't clear technology words.
Yeah. Yeah. And it was able, so to disable all communication to the outside world by default, but make it configurable, you can use Azure network policies in AKS. So yeah, it's, here, can send and receive traffic without limitations. So it kind of understood that I'm trying to limit access to the resources in my cluster, which is pretty cool. And then so it talks about what you should be doing. Calico network policies. Hey, yeah, that's fair. I mean, that's a pretty good response. Azure CNI. That's what I was looking for, really. Because right now we're using KubeNet, which is kind of like the default de facto right now. But with Azure CNI, you can do a whole lot more. I'm also looking for other things, but
It's pretty good.
Decent response.
I wanted it to say Azure CNI overlay, but it's possible it didn't, meet your requirements. So
Yeah.
learning.
And then it gives you some links to references, which is pretty cool. So if you want to dive in, you can obviously ask it some follow-up questions, like what's the difference between Azure Network Policies and Calico? What is the Azure CNI Network plugin? But you can also click onto these links too, which is great. The other thing that I like to use, especially during preview, is hit the thumbs up or thumbs down button. If you get an answer that's like totally off, don't hesitate to give it a thumbs down. Like I do that, and then you can provide feedback as to why. So this is in preview. We are trying to make the product better. So let's see, what's the next one? Operating your AKS cluster. Now we probably won't have time to go through all of these, but let's just say this is a fairly new thing. Let's see if it kind of understands. How can I enable long-term support onto my AKS cluster, right? So I know we have some enterprise customers that are kind of looking for LTS.
For Brian, this is an easy one. So, it better be smarter than me.
Let's see how it does. How can I enable long-term support? Working on it, determining what to do. And I think you had like one question that you wanted to ask it in particular, right, Brian?
Well, yeah, I think the kind of things that come to me that, maybe I'm just not willing to learn, but it's usually like a Prometheus PromQL query. Like I'm supposed to write one. I'm not a real administrator in real life. So how do I write a Prometheus query that will tell me, average CPU utilization on my nodes in the cluster? Like something to that effect.
That's a great question to ask because I am not the best PromQL writer. So let's try to ask it. So it says here, look at this answer. To enable LTS on the AKS cluster, you need to move your cluster to the premium tier. And then both the premium tier and LTS support plan must be turned on or off together. What do you think, Brian?
That's exactly what I would have said. I mean, it added a couple extra details like that to make sure you understand it. But it even
Yeah.
says, like, as a follow-up question, like, what are the benefits of the premium tier? Like, I could ask that and get a little more detail. I mean, this is great.
Yeah. Oh man, that's pretty cool. What's that question that you wanted from PromQL?
So
I know we have 5 minutes
how do I
remaining.
how do I write a Prometheus query for average CPU in my cluster? I don't know.
Okay.
And this is definitely one that frankly I haven't tested. So
Yeah. We'll see. We'll see what it does.
and
If it's terrible, I'll give it a thumbs down.
honestly, like you said, it's a preview and we're learning from what people, but it's literally learning from these questions. So it's not even like the thumbs up and thumbs down literally go back into the training process. So
Yeah.
these things are super important.
Oh, okay. So what I said about the selected resource having something to do with the way Copilot responds, I think that is a thing.
I don't mind that answer because it's sort of like, hey, I can give you the query, but you don't even have the data in Prometheus.
You know what? That
There.
is so true too, because look, if I go to Insights, it's not on.
These robots are smarter than us.
Oh my gosh. That's fair.
Yeah.
That's very fair. Okay. So hope we all had fun with that. With about 3 minutes left on the call, let's just quickly recap what we did so far. So we all know AI is exploded onto the scene, and the recommendation, at least from me and some other folks here, like Brian, is to take a cloud native approach for bolting on AI into your applications. And when you do take a cloud native approach, AKS is a great platform for it, right? We also looked at how we can simplify some of these deployments, especially with like sample apps and repos and things like that using AZD, Azure Developer CLI. And then we saw how easy it is to actually expose your applications using the AKS app routing add-on. And then, yeah, we had some fun. Azure Copilot for Azure for the win. So pretty good resource information for you all to learn more. So I would highly recommend, if you have access or if you can get access, hit up your tenant administrator or EA administrator and ask them to kindly fill out that form so you can have access to that. Okay. I would say a couple things that you don't want to miss out on is, number one, this is episode 1 of a 4-part series. So scan that QR code. You'll be taken to the registration page where you can register for all of the existing or all the remaining sessions. I'll be back next week, and then Steve will be back. We'll do more observability and monitoring, and then global scale, right? You wouldn't want to miss out on that. And then Brian.
Yeah, I mean, by the way, all of those series, sometimes there's different speakers. They don't necessarily have to deal with Brian Redmond on all of them. But yeah, we're very reachable. Like, we put some links in the chats here around some of the open source links to some of the code that we've used here. Our Twitter links are right there, kind of on our titles. We also have an AKS community YouTube channel that we encourage you to take a look at. If you're watching this on that channel, obviously you know about it. If not, you're one of our other streams. We encourage you to follow this channel. We put content out there like this, like live sessions. We also put short videos, and we've got a lot of plans for it, for additional content that we're adding there to help you learn about AKS and building intelligent apps and things like that. So come find us, ask questions, offer help. We'd love to hear from you.
Awesome. So with that, I think we are all out of time. Thank you, everybody that stuck with us the whole time. Thank you, everybody that came back to the recording to watch us at the end. Appreciate you all, and we will see you next week. So
10 seconds of waving. 10 seconds.